Doing long division. So, and you've done long division. I'm just going to review with you. This is just going to be back in elementary school here. 5 goes into 148. 5 goes into 14 two times. 10, draw your line. You're subtracting, so you switch your signs. You're going to bring the ones cancel out, bring down your 4. 14 take away 10 is 4, bring down your 8. 8 times 5 is 40. Change your sign, make this an 8. This is called the remainder. Whoops, I could have went more than that, sorry. That should have been 9, not 8. 45, subtract remainder of 3. This concept is very similar to what we're doing, except instead of numbers, as you can see, they're polynomials. So you're going to put an x plus 2 on the outside, and you're going to put an x squared plus 6x minus 10 on the inside. Okay, you compare the x with the x squared. You always compare the first term with the first term. And in order to get from there to there, you would need an x up here. And then you multiply it by that and by that, and you're going to get x squared plus 2x. Just like we drew a line underneath, you're going to draw a line underneath. We didn't keep it a positive 10, we switched it to a negative 10. You need to switch your signs from a negative and a negative, opposite signs. The x squares cancel each other out. 6x take away 2x is 4x. Bring down your negative 10. And then you start it again. You compare your first term with your first term, and you need a plus 4 up here. You take this and multiply it by the x, and you also take it by 2. So you get 4x plus 8. You draw your line. Don't forget to switch your signs, because that's what you would have done when I showed you up above. The 4x cancel out. You're going to get a remainder of a negative 18. Okay, we're going to do a couple more of these. It looks like we have 3 more to do. So I think you're going to get pretty good at this after 3. So I'm going to put x minus 1 on the outside. And the inside part has to go in decreasing order. So the 3x to the third goes first. The x squared goes second, and the minus 4x goes third. Make sure it's in decreasing order. You compare the x with the 3x to the third, and it needs a 3x to the second on the top. You take this and multiply it by that, and that's how we get 3x to the third. You also have to take it and multiply it by that, negative 3x to the second, and draw your line, and switch your signs. The 3x to the thirds cancel each other out. You have 1x squared plus 3x squared gives you 4x squared. Bring down your negative 4x. Compare this one with this one, and you need a 4x. 4x times x is 4x squared. 4x times a negative 1 is a negative 4x. Draw your line, but don't forget to switch your signs. It just so happens that this one has no remainder. And in elementary school, when you did long division, sometimes you have no remainder. Okay, 2 more, and I think you're going to get pretty good at this. So this one's a little bit different, so I wouldn't shut off the video yet. I'm going to put the a plus 2 on the outside, and on the inside, I'm going to put 2a to the third plus, now here comes the kicker, this is a new thing. Do you notice that it goes from power 3 to power 1? It's missing power 2. You need that in there. But by putting 0 in front of it, it's not really there. And then copy the a and copy the 3. And I'll show you in a minute why you have to put the missing terms in there. Now it goes 3, 2, and 1. It needs to be in decreasing order without skipping a power. Compare the first term with the first term, and you need 2a to the second. If you took this times this, you get 2a to the third. If you take this times this, it makes 4a to the second. Aha! If this wasn't there, you would align the 4a to the second with the a to the first. You see why you need it? So that you can align the right powers with the right powers. So that's why it's there. Draw your line. Don't forget to switch your signs. These two cancel out. If you have 0a squares and you take away 4a squares, you're going to have a negative 4a squared. Bring down your a. You compare the a with a negative 4a squared, and it's going to be a negative 4a. A negative 4a times a is a negative 4a squared. A negative 4a times 2 is a negative 8a. Draw your line, and don't forget to switch your signs. The a squares cancel out. A plus 8a is 9a. You still have to bring it down until you can't bring anything else down. Bring down a negative 3. This is going to end up being a positive 9 because when you compare the 9a and the 1a, it's missing the 9. This is going to be 9a plus 18. Draw your line, switch your signs. You're going to get a remainder of a negative 21. And the last problem. Let's do one more and this will be it. You could shut it off if you understand what you're doing. I'm just going to do one more. So the 3x plus 1 goes on the outside. I'm just going to maybe go a little bit faster. 12x to the third minus 2x to the second plus x minus 9 goes on the inside. You compare the first term with the first term, and you need a 4 and an x to the second. You need to take that and multiply it by that and that. So you get 12x to the third plus 4x to the second. Draw your line, switch your signs. These cancel out. A negative 2x squared minus a 4x squared is a negative 6x squared. Bring down your positive x. You compare this one now with the new first term. It's going to end up being a negative 2x. Negative 6x squared, a negative 2x. Draw your line, switch your signs. They cancel out. 3x, still bring down the negative 9. You compare the 3x with the 3x and don't say nothing. 3x goes into 3x one time, not 0 times, because what's 1 times 3x? 3x. What's 1 times 1 plus 1? Draw your line, switch your signs. In this problem, you have a remainder of a negative 10. Just watch out for missing powers. That's all I ask. Okay, worksheet.